Hello friends, today we are going to answer the questions which are 2 marks questions of solid state and physics paper, okay, of all the 3 years, previous 3 years, 2021, 2022 and 2023 of 5th semester, Dibrugarh University. And before we start, please do subscribe the channel, also hit the thumbs up button, also share with your friends, inspire me to create new contents for you. Now you say, and if you want to follow me on Insta, this is my Insta ID, Lakhyajit 123, Oza Lakhyajit 123. This is my Insta ID, right? So let's start. Now here you see, these are the questions from 2 marks questions from 2022 paper. So first, here it is given define unit cell. If the unit cell has following characteristics, then identify which crystal does the unit cell belong. So first let us define what is unit cell. Okay, this definition of unit cell is also asked in 2023 paper as well. Okay, so let me give you the definition. So unit cell can be defined as unit cell. So here you see, you can define like this. In every crystal, some fundamental grouping of particles is repeated, right? Such fundamental grouping of particles is called unit cell, is called unit cell. This is the definition of unit cell. Now what is the next part of the question? So these are the informations given, informations of a unit cell. Okay, so we need to answer that this unit cell belongs to which type of crystal. Okay, to answer this question, check this table here. You see, here this A and B are equal, C is not equal, so this condition is satisfied. Then alpha, beta, gamma all are 90, this condition is also satisfied, right? So that's why it is tetragonal. Okay, answer should be tetragonal. This is the answer to this question. Okay, so remember this table. Okay, take the screenshot. Now next question is 2b. Define geometrical structure factor. How does it relate to the atomic scattering factor? So let me answer this question. So here is the definition of geometrical factor as geometrical structure factor, and this is the relation between geometrical structure factor and the atomic scattering factor, right? And this is the required relation. Okay, so hope you have understood. Now question number 2c of 2022 is this. Okay, state Dulong and Petty law of specific heat of solid. So what gonna be the statement of this law? So here is the answer to 2c. Okay, Dulong-Petty law. So though the question is asked state the Dulong-Petty's law, right? So only for statement 2 marks will not given, right? And I haven't got such one sentence statement in any book, so just you must write these things. Okay, now let's move on to next question. Next question is, what is optical absorption and infrared absorption in dielectric? Here is the optical absorption and infrared absorption. So optical absorption occurs when dielectric material absorbs light in the visible to near violet region of spectrum. Then infrared absorption refers to the material's absorption of light in the infrared region due to the vibration modes of its atoms and molecules, right? So this is 2D, right? Now let's move on to next question. Next question is 2E. So here you see piezoelectricity. Give an example of crystal that is piezoelectric but not ferroelectric. So let me give you that answer. So here is the definition of piezoelectricity, and the example you need is this one, quartz. Okay, so now let's move on to next question. So this was question number 2E answer. Question number 2E, take the screenshot, right? Now let's move on to the next question. So 2F, what is Hall effect and what important conclusion can be drawn from the Hall effect? Okay, let me show you. So what is Hall effect? You can write it from here, okay, and draw the diagram as well. Okay, so now what important conclusion can be drawn from this Hall effect? Now you see the information, what important conclusion or information can be drawn from this Hall effect is that we can we can write from here. Okay, when you have to write what is Hall effect, so write this part, and information can be drawn from Hall effect. Here you can write the Hall effect can be utilized to distinguish between the two types of carriers, also allows density of charge carriers to be determined. Okay, and which these informations can distinguish between positive holes and electron conduction, right? Okay, and using which we can determine n type, p type, a sample is n type or p type, that can be determined. Okay, so what's next? So there is another 2 marks question, which is question number 3A. Obtain the Miller indices of the planet's intercepts at this, and this. So what are the intercepts here? A, B by 3 and 2C. Okay, of a simple in a simple cubic lattice. So here we have 1, okay, 1, then 1 by 3 times of B and 2 times of C. So Miller indices should be reciprocal of those. Okay, 1 by 1 is simply 1, 1 by 3 its reciprocal is 3, and reciprocal of 2 is 1 by 2. So this is the, so these are the Miller indices of the plane. Okay, that's how we can do. So hope you understood this. When you write the Miller indices, write within the bracket, small bracket, 1, 3 and 1 by 2, write within the bracket. Okay, 1, 3 and 1 by 2. That's how we used to write the Miller indices. Okay, so hope you have understood this. So what is the next question? Let me answer this question, and let me tell you one more thing, don't use comma here within this bracket. Okay, so next question is here 6B. What is the penetration depth for a superconductor and what is its value at critical temperature? So let me answer this one as well. So this is the definition of penetration depth and its value also. At critical temperature, that should be infinity. Okay, here what is here it is what is its value at the critical temperature, that is infinity, right? So definition of penetration depth is this one. This is the definition. Okay, now we're going to solve the questions of 2 marks questions of this 2021 paper. Here question number 2a is draw this 110 plane. So here this is Miller indices. Miller indices are given. So reciprocal of 1 is 1, reciprocal of 1 is 1, and reciprocal of 0 is infinity. So now you see how to draw this. Let me show you. A plane are given 1 1 0. What does it mean? So if you take the reciprocal, so so let me first draw this. Just 1 minute. This is x y z coordinate. This is x, this is y, this is z, and let me make the unit cell. This is the unit cell. Let me draw it. Okay, this is the unit cell, and let me complete this one. So here this is 1 at x, this is 1 on y, this is 1, this intercept is 1 on z. So here reciprocal of this one is 1 and reciprocal of this one is 1. This is x intercept, this is y intercept, and reciprocal of this one is 0 is infinity, that is z intercept. So that means the plane is it is a plane such that it doesn't intersect z axis, right? It is parallel to z axis. So this plane should be like this. Here you see this plane should be like this. This should be the plane, okay, which is parallel to z axis, but this plane is intersecting your x and y axis. So this is the plane, right? So hope you have understood this. This plane is coming this way, which is parallel to z axis, right? And intersecting x at 1, y at 1, right? So hope you have understood this. This is the plane. So now let's move on to next question. Next question is define primitive cell, primitive unit cell. Can unit cell be a primitive cell? So let me explain this. So 2B of 2020 one paper. So here you see what is primitive cell or primitive unit cell, right? Primitive unit cell is the unit cell that contains one lattice point only at the corners, right? At the corners. And one more thing, that is unit cells may be primitive, okay? Unit cells may be primitive, but all the primitive cells need not be unit cell, okay? So that means a primitive may be unit cell, but it is not necessary, okay? And you can define this primitive cell this way. It will be okay, sorry. So let's keep this answer this way only, okay? Just take the screenshot. The next question: what is phonon? What is the which states statics does it obey? So definition of phonon: a phonon is a quantized mode of vibration occurring in a rigid crystal lattice. Okay. Due to, so these vibrations occurs due to the atoms in the crystal lattice are not static but oscillating, right? Due to oscillations of the atoms of atoms in a crystal, right? And what kind of statistics does it follow? So that is it obeys Bose-Einstein statistics. Bose-Einstein statistics. Okay. Now question number 2D. Does electric constant vary with frequency of applied field? Write the relation between the optical constant and the complex dielectric constant of medium. Okay. So does dielectric constant vary with the frequency of applied field? Okay. Write the relation between optical constants and complex dielectric constant of medium. So let me answer this question. So answer is obviously yes here. Okay. Dielectric constant vary with frequency of applied field. Let me write the answer. Dielectric constant, it has two parts. One is real. This dielectric constant is a function of this frequency of the applied field. So it has real part and one is imaginary part. Okay. So this is imaginary part. The real part of the dielectric constant. This. Okay. So this is the relation with the optical constant. So what is the next question? Now next question is, what are Curie law and Curie temperature? Let me give you the answer. So here is the answer. This is the Curie's law and here is the definition of Curie temperature, right? So take the screenshot. Now let's move on to next question. So this is the next question. Draw the potential experienced by an electron in Corning-Penny model. So let me show you the answer. Here is the answer, 2F, right, of 2021. So now next question is, what are the conditions for a material to be superconductor? So let me write the conditions. So here these are the conditions for a material to be a superconductor. This is the first condition, this is the second condition, this is the third condition, and this is the fourth condition. So these are the four conditions. Let me show you again one by one. This is the first one, take the screenshot. This is the next one, and then this is the third, and the last one is this. These are the conditions. Okay, so now let's move on to next question. So now 7a, define penetration depth related to superconductor when it is placed in an external magnetic field. I think I have already given this definition. Here you see in 2022 paper this was asked, where was it? So this is penetration depth for a superconductor. That was the definition, right? So I don't think I need to define it again, right? So now next question is B, 7b, draw the dispersion curve for linear diagramic lattice showing acoustical and optical modes. So here is the curve, required curve, okay, for this question. For this 3b, not 7b actually, sorry, 3b. In 2021 paper, this question is given in 3b. Question number 3b, 2021 paper, right? So this is 2023 paper. So define unit cell, already we have defined, and atomic packing factor. What is atomic packing factor, right? So atomic packing factor, atomic packing factor is defined as, it is also known as relative packing density, okay, relative packing density is defined as the ratio of the volume of the atoms occupying the unit cell to the volume of the unit cell relating to the structure of the crystal. So this is the definition of atomic packing factor. Now define atomic radius in crystal, calculate atomic radius in case of BCC lattice. So let me show you. So atomic radius, this is question number 2b, okay, 2023 paper, 2b 2023 paper, right? Question number 2b. So atomic radius, sorry, let me write it properly. Atomic radius is the distance between the two centers of two neighboring atoms, right? And how to calculate the here is the next part, atomic radius in case of BCC lattice. Okay, how to calculate that atomic radius of BCC lattice? So for BCC lattice means body centered lattice, okay, body centered cubic lattice, that is BCC lattice. That means here we have, you know, one fourth of an atom. Here you see, sorry, not one fourth, 1 by 8 times of an atom, right? So now you see, because you see, suppose this is one, here you see one unit cell. This is, it's one unit cell, another unit cell should be there, okay, like this, and this is one unit cell, and such kind of another layer behind it, okay. In that case, that the atom here at this position, you can consider at this position, the upper half of the atom will be divided into 4 parts, and lower half of the atom will be divided into 4 parts. So here we got 1/4 parts here, right? So this is not our concern. If you consider the radius of this atom is r, so its diameter gonna be twice r, right? And this radius is r. So, and if you consider each edge of this cell is suppose a, and so this diagonal of this square, bottom square, this is a, so this length will be root over 2a square, that's gonna be root 2a, right? Sorry, a root 2, right? So here from this triangle you see root 2a, and here it is a, so what will be the length here? And this is a, this is b, and this is c, suppose this is b, so a, b and c. So if you check, then what you're gonna have, ac square is equal to ab square plus bc square. So this length is generally from this diagram, what we have got 4r, right? This r plus twice r, then this is r, 4r, right? So r is the radius of atom, or atomic radius in that case. So what we're gonna have, then here ab square will be simply small a square, bc square will be a root 2 square, and ac square 4r whole square, 4r whole square. So that's why we're gonna get here you see, if you take the square root, then you, what you gonna have here, you 4r gonna be equal to here a square plus, here it will be a square into 2, that's gonna be root 3a square. So r will be equal to root 3 by 4a. So this is the atomic radius for BCC lattice, right? So hope you have understood this. So what is mean by hysteresis in magnetic material? So let me give you the definition. Here is the meaning of hysteresis in magnetic. Okay, so take the screenshot. So now let's move on to next question. Next question is, draw the 1-1-1 plane for a simple cubic structure. So here Miller indices of the plane is given. So let me take a new slide. Let me make it, this is y-axis, this is x, suppose this is z-axis, okay, x, y and z. Let me make the unit cell, this is the unit cell, suppose, sorry, let me draw it properly. So okay, so this is the unit cell, suppose, okay. So now Miller indices 1 1 1, this Miller indices. So x intercept will be 1 by 1, that is 1, y intercept will be 1 by 1, that is also 1, z intercept will be 1 by 1, right? So such a plane which is intersecting x, y, z, all the 3 planes. So like this is the plane, right, which is intersecting x, y, z at 1 1 1, right? So when Miller indices is given, here you have to take the reciprocal, okay? First take the reciprocal. Next question is, what are Curie law and Curie temperature. We have already done this question, right? So here you see where we have done just this one, question number 2E of 2021. So same question is here. What are Curie law and Curie temperature? We have already given. And what is penetration depth? Already defined and explained briefly. So I think what I have given in this, where is the question? Okay, this is the question, penetration depth. So just write this. Okay, let me give you a brief description. Okay, penetration depth and its brief description. Just wait. So here is the answer to the last question. This is the definition, and you have also write this part as well. Okay, this is the first page, this is the second page. Take the screenshot. Okay, first, and this is the last. So we have solved all the we have answered all the 2 marks questions of 3 years questions, 2021, 2022, right, and 2023. Okay, so hope this answer is gonna help you. So I'll make another video where we're gonna discuss about long questions. See you in the next video. Thank you for watching. See you in the next video. Bye bye.